So welcome again. In this particular lecture we'll be discussing about surface finish symbol which are mentioned on engineering drawings. So before going further into the lecture, we should understand what do you mean by surface finish. So whenever you manufacture a component by any machining processes like turning, milling, drilling, the surface develop a type of texture, but to naked eye the object looks or the surface looks perfectly flat, but when you see it under a microscope you can see the irregularities. So those irregularities are called as your surface roughness. Surface roughness plays a very important role when a critical component are being assembled. So critical component means, let's say I'm talking about a piston cylinder assembly. So where piston and cylinder, both the component should be manufactured with a precise surface roughness or precise surface finish value which a manufacturer expects. Okay, so in such cases it is very important to maintain the required value of surface finish. So the person who is doing the drawing will give you that what value of surface roughness is expected through a symbolic representation. So it becomes important for you to understand that symbol. So before going into that symbol, discussing the meaning of symbol, I'll just elaborate what are the important factors which affects the surface finish when you are manufacturing a component. So obviously the first one is the material of the workpiece. So if the material is ductile, the surface will be smooth. If the material is brittle, the surface can be rough. Okay, type of machining process that you adopted, like if you're going with higher speed, lower feed, lower depth of cut, the surface will be generally smooth. It will have a very fine surface. But if you go with higher depth of cut, lower cutting speeds, such type of machining parameters, the surface is expected to be rough. Vibrations which are produced during the machining process can affect your surface finish. The cutting tool, like if the cutting tool is brand new, if the cutting edge is very sharp, it is very easy to remove the material and your surface will be proper, surface will be good. But if you're using a tool which is worn out, which is old, then the surface while machining may be turn out to be rough. Okay, so all these factors will affect your surface finish, so you need to take care of these factors whenever you are machining. Okay, so I was talking about surface roughness. So on microscopic level your machined surface will look like this. So will look like this means if you see it under microscope you will see some sort of peaks and valleys, right? So this thing is called as valley, this thing is called as peak. So the repeated pattern of this peak valley is called as your surface texture, which you call it as surface roughness. Okay, so surface roughness or getting this object with a smoother value of this peaks and valleys is very important. That's why we are understanding the meaning of surface roughness. Okay, so this is what I was talking about. This is your typical surface roughness symbol which you will have on a drawing. You will get such type of symbol on drawing, not like this. This is the explanation of the symbol. This is what you will get on an engineering drawing. Okay, so let's discuss this symbol. So I'll explain this symbol. On typical drawing you will get a symbol like this, which is like a square root symbol that you might have used in mathematics. So what is the meaning of this symbol? So this symbol will have a triangle completed by this inclined line and a sloping line. So this part is called as machining method. Like if a particular object needs to have a particular surface roughness, I can specify the method by which, or a machining method by which I can obtain the surface roughness. Okay, this part of the triangle, that is your base of the triangle, is called your roughness value. That is the mathematical value or a value that you want after the machining process is over. This part will mention the machining allowance, this part will mention sampling length, and this little part will mention direction of lay. Now we'll understand this entire thing through this symbol. So here on an engineering drawing or on a particular product drawing, this symbol was mentioned. So how you should read it? So I should read that a person wants a surface roughness of 4 micrometer on that particular surface or on that particular part. That's what his surface roughness requirement is, 4 micrometer. For that 4 micrometer, he has given me that I can achieve that 4 micrometer value by a machining method called as grinding. But let's say he has not mentioned the machining method. That means you are free to use any method of machining, but your surface roughness value should come 4 micrometer after doing that machining method. Okay, so by using grinding, you are supposed to bring surface roughness of 4. But again, there is one thing, machining allowance. Machining allowance means how much material you are supposed to remove, because all the machining processes are subtractive machining processes where you remove some amount of material. So what this symbol is telling me, that to manufacture the product with surface roughness of 4 micrometer with grinding process or grinding machining method, I should or I am allowed to remove material up to 0.5 mm. That's what this 0.5 is telling here. Okay, now next symbol is this lay, direction of lay, and this is sampling length. Sampling length means, let's say I have done grinding, I have removed 0.5 mm material, and I want to verify by a surface roughness tester, which is an instrument to measure surface roughness value, that whether I have achieved a surface roughness of 4 micrometer by this process. So for that, I'll be taking a sample of 5 mm only. Okay, so on a 5 mm sample, I will measure my reading, and direction of lay here is perpendicular. So what do you understand by lay? Like if you're doing turning operation, the lay that you form onto the component is circular. Like lay is nothing but machining marks. Okay, so let's say if you're doing a knurling operation, so what type of lay you form? Zigzag. So lay is nothing but the machining marks which are left after machining. Obviously you don't see them with the naked eyes, but if you go in the microscopic level, you can see those. That's what this lay is. So here lay is perpendicular. So I'll just summarize what this symbol is talking about. The symbol is talking about surface roughness of 4 micrometer should be arrived by grinding of a component up to 0.5 mm only. So after grinding the material for 0.5 mm, I should take a sample of 5 mm and should measure 4 micrometer of surface roughness. This is what this symbol is talking about. Okay, so it's not like every time you will be having this complete symbol on your drawing. Sometimes this symbol can be like this. So see this next slide. It can be represented in this many forms. So how to interpret if such symbols are present? So first case is this symbol. See, if such kind of symbol is there, you should understand that this surface may be produced by any method. Like there is no compulsion which machining process I should use to arrive at mentioned surface roughness. Like here in the last example, I was made a compulsion of grinding method to arrive at 4 micrometer of surface roughness. Grinding process should be followed, but here this symbol doesn't talk like that. This symbol says you are free to use your own machining process, whichever you like, but thing is you should arrive at whatever value of surface roughness I have mentioned. Okay, let's say if you are given such kind of symbol, so if such kind of symbol is mentioned on any of the surface or any of the feature on the drawing, you should understand that you are not supposed to remove a material from that surface. That means material removal processes is not allowed. You are not supposed to machine it. That is what this symbol is talking about. It is very rare that we use such kind of symbol, because when the component is manufactured by any of the machining, any of the manufacturing process, in order to bring it to desired shape, desired dimensions, you have to do some sort of machining processes like turning, drilling, milling, facing, etc., etc. So it's very rare. What this symbol is talking about? This symbol is talking about that your allowance is 3.5, like while to achieve the mentioned value of surface roughness, which was 4 in our last case. So let's say again we will assume 4 micrometer here. So to arrive at 4 micrometer of surface roughness, I am supposed to remove material up to 3.5 mm, but again the machining method is not compulsory. I can use any machining method of my choice. I can use grinding, I can use drilling, I can use milling, I can use facing, anything or any machining process that you want to use, but again the material removal is allowed up to 3.5 mm only. Okay, so this is the complete symbol. We have already discussed this. So surface roughness symbol has the gradings or grade numbers from N1 to N12. Okay, N1 to N12. So surface roughness symbols can be represented by this entire symbol, or in some cases it can be represented only by triangle, like 1 triangle, 2 triangle, 3 triangle, etc. So in the next session maybe we'll see such drawing. If it is available here, I will just show you to you so that you can understand what I want to talk about. Now this thing was talking about the lay. It is the letter D. Lay is nothing but direction of machining. So these are the some examples of lay. So this symbol represents parallel lay. So see here, this is a plate where you are doing machining in this direction. So in whichever direction the machining is done, in that particular direction only you are supposed to take the surface roughness reading. That is what lay is. Let's say perpendicular is the lay. So here you are machined in this direction, but while taking the measurement reading of surface roughness, you should travel in a perpendicular direction while measuring the surface roughness value. Similarly, X type, so this type of lay you will get in knurling operation, right? This type of lay, parallel lay, perpendicular lay, you will get in the in case of face milling operations or in end milling operations. Okay, this is very common. You might have studied in first year or second year level. Circular lay, so this is circular lay. So if you are turning a job on a lathe machine, the lay or a machining marks that you get are in the form of circle. That's why it is called as circular lay. Got it? So these are the meaning of lay. So symbols, I will revise again. So this symbol is surface roughness symbol, where machining method required is milling, sampling length is 2.5, the lay is perpendicular, allowance is 2 mm. Okay, so if you read it out, see, if you read it out, this one example again here, so you can see this symbol. So again, by looking at the symbol, you should understand the person who has made the drawing is talking about the surface roughness. So he is expecting some value of surface roughness there. Okay, so how do you read it out? So what is this? Machining method. So in order to achieve the mentioned value of surface roughness, which is not mentioned here, let's assume I want surface roughness of 4 micro mm again here. So in order to achieve surface roughness of 4 micro mm micrometer, the surface should be milling is one operation. So by milling only you are supposed to achieve the value of 4 micrometer. Okay, so in order to achieve 4 micrometer of surface roughness by milling method, the amount of material that I am allowed to machine or allowed to remove is 2 mm, which is your machining allowance. Okay, so after milling, after removing 2 mm of material, you want to verify whether you have got the required value of surface roughness. So for that, the sample on which you should take reading is of 2.5 mm only. So on the 2.5 mm sample, you should measure the surface roughness. You should use your surface roughness tester, and the lay that you should follow is perpendicular. So in whichever direction the machining marks are, your measuring instrument or your surface roughness tester should travel in the perpendicular direction of that. So this is what your surface roughness symbol is. So see, this is very small topic but has a huge importance, because many times these symbols are there on the drawing but students simply do not understand them. So it's very important that you understand each and every aspect of the engineering drawing, because they are with some purpose. Because in production, if there are errors at manufacturing end and part is going for quality control, and I see that whatever things were mentioned on the drawing are not achieved or are not satisfied by the manufacturer during quality control, I cannot pass that component, so I can scrap it or I can rework it. So this is unnecessary rework or unnecessary wastage. That's why it is very important for a person who is working in shop floor or in manufacturing environment should understand the drawing. Like understanding front view, top view, side view is one aspect, but on that front view, top view, side view of the drawing, there will be this geometrical symbols or this geometrical tolerances or geometrical dimensions or surface roughness symbols or welding symbols will be there. Okay.